Hello and welcome you all to another lecture of Islamic concepts. So we are going to discuss light. We have discussed reflection, isn't it? Last class we have discussed spherical mirror. And spherical mirror has two types, that is concave mirror and convex. And we know how to identify the mirror. If you don't know, go to the previous lecture and you can find it out. So first of all, we have to know about some terminology related to the mirror. You can say spherical mirror. Let's say, first of all, identify what type of mirror is that. We know cave part. Cave is towards the center. So we can say this one is concave mirror, isn't it? So this one is concave mirror. Similarly, we can write convex mirrors like that. Write convex mirrors like that. Reflecting surface in that one and that side will be. So whatever will be the mirror, then it can be concave or convex. There is some terms are there. First of all, we have to know what is center of curvature and write it as C. If we consider this is basically a mirror. If we take a circle of that mirror, so that circle, center of that circle represents center of curvature. So if we take this one is a circle, so center of that circle is basically center of curvature of that mirror. Okay, so here for concave mirror, convex mirror, that one will be center of curvature. So we can write C as center of curvature. Here. Now we can write, here we have to know about the mirror. This one is basically mirror, that one is imaginary line. That is why I have taken that as a dotted. Now take this one is M, this one is M dash. That one is mirror, and in between point M and M dash, this one is as pole. Okay, and the line which goes through the center of curvature and pole is right as the principal axis. So this one is principal axis. Okay, and P is basically what? Pole. And if we take this, we have to prove a relation, that is F equal to R by 2. That is focus is with, if we take PC basically the radius of curvature. Radius of curvature, what is radius of curvature? Radius of curvature is the distance from center of curvature to the pole. So PC is radius of curvature. Okay, and that will be represented as R. Okay, and there is a point that is focus which is in between center and focus, center of curvature and pole. So this is F, and we can write CF is equal to FP or TF. Okay, FP. And that distance you can say from center, that distance will be F. That one is F, that one is also F. So we can say it R equal to F plus F. So we can say R equal to 2F. So from here we can write F equal to R by 2. So this will be our expression to solve mathematical problems from this problem, this formula. Okay, that one is very basic. So from that we can know that is center, that is focus, that is pole. Total distance from center is R, and CF and FP is basically F. Okay, now Similar case will happen for convex mirrors. First of all, know about concave mirror, and we can relate it that from convex mirror. That one is principal axis, that one is basically focus, that one is pole. So similar thing happen for convex mirror. Now we have to know about some laws related to the mirror. If a light ray comes to the parallel to the principal axis, if a light ray comes parallel to the principal axis, it will go through focus. Okay, if come from parallel to the principal axis, it will act through the focus. Similarly, if a light ray comes through the focus, it will reflect it back through the parallel to the principal axis. Okay. Similarly, if a light ray parallel to the principal axis, so it will go through focus. And similarly, if a light ray comes through focus, it will go to the parallel to the principal axis. Here, next, we can say if a light ray comes from the center of curvature, it will move back to the same. That is, if a light ray comes from center of curvature, so it will move back to the center of curvature. Last but not least, if a light ray comes at an angle, let's say light ray coming at an angle, let's say theta, it will reflect it back an angle with theta, following the laws of reflection. If a light ray comes at an angle of theta, so will reflect it back angle of theta. Okay. This one is basically incident ray, and that one is reflected. Yeah, you have to know about these 4 rules. First rule is parallel to the principal light ray, parallel to the principal axis, it will move back to the focus. And if a light ray comes through the focus, it will move back parallel to the principal axis. If a light ray comes to the center of curvature, it will move back to the center of curvature. And if a light ray comes angle of theta, it will be reflected back at the angle of theta, following the laws of diffraction. Okay, these are the basic rules of incident ray and reflected ray when it comes to the spherical mirror. Similar case will happen for convex mirror, so we don't need to go to that one. We will conclude from here that this whole law will be very much applicable when you place object at different position. So next class we will know about what will be the nature of the image when we place the object in different positions. Clear?